Welcome back, faithful viewers, to the Stellar Twin Voyagers program. Today, I, Nova A239, will once again guide you through the journey of the siblings striving to fulfill their colorful dreams. Let's explore the eternity of a million eras amidst the sea of stars together. Get ready to be enchanted by the wonders of the universe and stories full of hope that inspire us all. The lunch break has ended. Grandpa and Dad have returned to the fields to work, while our young shepherds Aster and Cosmo are tidying up their lunchboxes and preparing to return to the fields. Alright, we've tidied up. Now let's go meet Grandpa in the field, said Aster. Let's go, bro, replied Cosmo. They approached their grandpa and dad in the fields, helping to cover the seeds they had planted and watering them. Slowly, they worked together, managing to finish 3 plots of land, and the day was already turning late as they completed the 3rd plot. The work in the fields for today is almost done, Aster, Cosmo. Let Dad and Grandpa handle the rest here. You two head back and take our sheep grazing, said Dad. Okay, Dad, both sons said, packing up their tools and heading home towards the sheep pen. It's time for afternoon meal, Mrs. Sheep, Cosmo said as they reached the pen door and opened it. Aster then led the sheep out, and together they grazed them in the grasslands, letting them drink water. Alright, it looks like our flock has eaten their fill. Let's bring them back, it's getting dark, Aster said to Cosmo. Cosmo nodded, and they both guided their flock back to the pen, then quickly ran back home. Mom, we're back, said Aster and Cosmo as they entered the house. Oh, Grandpa and Dad are back too, bro, Cosmo exclaimed happily. Oh, my grandchildren are back from grazing the sheep. Come on, let's all gather at the dining table, Grandpa said. Alright, Grandpa, Aster and Cosmo replied. They quickly changed into clean clothes and bathed in the backyard, then joined their parents and Grandpa in the kitchen. Wow, my sons are smelling fresh. Come sit here with Dad, said Dad. Alright, Dad, they replied and sat down together. Oh, Aster, Cosmo, said Grandpa, tomorrow Grandpa and Dad won't be working in the fields. Grandpa has a task to give guidance to the village farmers about superior seeds and planting techniques. Your dad will accompany Grandpa. Do you want to come along? It's mostly adults attending the event at the village hall, Grandpa isn't forcing you. You can stay with Mom at home if you don't want to join Grandpa and Dad. I want to come, Grandpa, said Aster enthusiastically. Me too, added Cosmo. Grandpa smiled, patting their heads. Alright, it's settled then. We'll have lunch with the villagers at the village hall, so you don't need to pack lunch from Mom. Nantuku, tomorrow just prepare breakfast and dinner, alright. We'll have lunch at the village hall. Alright, Dad, Mom replied to Grandpa. And also, dinner is ready. Let's eat together, Mom added. Enjoy your meal, they all said together. They then enjoyed their dinner happily. After dinner, Dad and Grandpa walked towards the front yard of the house to enjoy the gentle breeze while gazing at the starry night sky. Meanwhile, Aster and Cosmo helped their mom clean up the dinner utensils. When they finished, they approached their dad and Grandpa. Oh, Dad's sons have arrived. Come on, boys, put on warmer clothes. Today we'll enjoy the night sky again in the grasslands. Dad and Grandpa will wait here. Bring your flashlights too, Dad said. The 2 young shepherds quickly ran to their rooms to prepare themselves, then hurried back to meet their dad and Grandpa. Alright, now let's start walking, Grandpa said. As they walked, chatting along a forest trail, they eventually arrived at the grasslands. Dad spread out a mat, and they all sat down. Alright, Grandpa began. Today I'll discuss another interesting topic. But, what should it be? Son, do you have a suggestion? Dad thought for a moment, then answered, how about discussing the atmosphere and satellite orbits today? We should save the exciting part for tomorrow. Grandpa smiled and said, that sounds good. I'm looking forward to tomorrow as well. Alright, first, I'll explain about Earth's remarkable atmosphere. Although the atmosphere is just a layer of air surrounding Earth, it actually consists of several layers. Each layer has unique characteristics and plays a crucial role in sustaining life on Earth. First, there's the troposphere. This layer extends from 0 to 12 kilometers above the Earth's surface. It's the lowest and densest layer of the atmosphere, containing about 75% of the total atmosphere's mass and nearly all of the water vapor, making it the layer where most weather phenomena occur. In this layer, temperature decreases with altitude, averaging about 6.5 degrees Celsius per kilometer. Interestingly, its thickness varies, thicker at the equator about 17 kilometers and thinner at the poles about 7 kilometers. At the top of the troposphere is a transitional layer called the tropopause, which separates the troposphere from the stratosphere. The next layer is the stratosphere. Located at 12 to 50 kilometers above the Earth's surface, this layer contains the ozone layer ozonosphere between 15 to 35 kilometers, which absorbs most of the harmful ultraviolet radiation from the sun. In this layer, temperature increases with altitude due to the absorption of ultraviolet radiation by ozone. This layer is less turbulent and convective compared to the troposphere, making conditions in the stratosphere more stable. The stratosphere allows commercial airplanes to fly at certain altitudes due to stable air and lower resistance. At the top of the stratosphere is a transitional layer called the stratopause, which separates it from the mesosphere. The 3rd atmospheric layer from Earth's surface is the mesosphere. It extends from 50 to 85 kilometers above the Earth's surface. Temperature decreases with altitude, reaching a low of about minus 90 degrees Celsius at the top of the mesosphere. This layer is where most meteor combustion occurs, causing meteors to appear as shooting stars. The mesosphere is the most difficult atmospheric layer to study because its altitude is beyond the reach of balloons but too low for satellites. At the top of the mesosphere is a transitional layer called the mesopause, which separates it from the thermosphere. Fourth, there's the thermosphere. Located at 85 to 600 kilometers above the Earth's surface, the temperature in this layer increases sharply with altitude, reaching up to 2,500 degrees Celsius or more, although the air here is very thin. This layer contains the ionosphere, a layer rich in ions and free electrons that play a crucial role in radio wave propagation. The thermosphere is where auroras, northern and southern lights, occur due to interactions between solar wind and Earth's magnetic field. The thermosphere is also the orbit of the International Space Station (ISS) and other low-orbit satellites. At the top of the thermosphere is a transitional layer called the thermopause, which separates it from the exosphere. The 5th layer is the exosphere. Its altitude ranges from 600 kilometers to about 10,000 kilometers above Earth's surface, making it the outermost layer of the atmosphere where air particles are very sparse and can escape into space. This layer does not have a clear upper boundary but gradually transitions into space. The exosphere is where many satellites are located due to minimal air friction, allowing satellites to remain in orbit longer. Particles in the exosphere can travel very long distances before colliding with other particles, making it more akin to a vacuum than a dense atmospheric layer. Additionally, there are a few other things you should know. First, the ionosphere. This is part of the mesosphere and thermosphere ionized by solar radiation. This layer enables long-distance radio wave propagation and auroras. Then there's the magnetosphere. I think I've discussed this before. It's the zone around Earth influenced by Earth's magnetic field, which protects Earth from harmful solar winds by deflecting charged particles. Next, I'll discuss satellites, but let me rest for a bit. Son, would you like to explain to your sons? Of course, let's allow Grandpa to rest and you listen to Dad's explanation, Dad said. There are 4 types of orbits around Earth that Dad will explain. First, there's low Earth orbit LEO. This orbit is at an altitude of 160 to 2,000 kilometers above Earth's surface. Satellites in LEO orbit the Earth in about 90 to 120 minutes and have a high relative velocity of about 7.8 kilometers per second. The LEO region experiences significant atmospheric drag, affecting satellites in this orbit. LEO is used for various purposes. For instance, the International Space Station (ISS) is located around 400 kilometers above Earth, chosen for easy launch access and its proximity for scientific experiments requiring frequent resupply. Then there are Earth observation satellites used for mapping, weather observation, and environmental monitoring due to their high-resolution imagery. Additionally, communication satellites are used for high-speed data communication and satellite internet services like Starlink. Secondly, there's geostationary Earth orbit GEO. This orbit is approximately 35,786 kilometers above Earth's surface. Satellites in GEO have an orbital period that matches Earth's rotation period, 24 hours, appearing stationary above a single point on the equator. This orbit requires a higher launch energy to reach. GEO is extensively used for communication satellites, ideal for television, radio, and telephone communication due to wide coverage and fixed position above one location. It's also used for weather satellites like GOES, providing real-time global weather observations. The advantage of this orbit includes its wide coverage area, ideal for uninterrupted communication, and its fixed location, which is perfect for ground-based antennas. Thirdly, there's medium Earth orbit MEO. This orbit ranges from 2,000 to 35,786 kilometers above Earth's surface with orbital periods between 2 to 24 hours. Satellites in MEO have varying speeds and orbital times lower than LEO but higher than GEO. MEO is commonly used for GPS navigation, where navigation satellites like GPS around 20,200 kilometers use MEO to provide global coverage and accurate signals. It's also used for GLONASS and Galileo navigation systems, operated by Russia and Europe, respectively. The benefits include a combination of wide coverage and good resolution. Additionally, MEO is less congested compared to LEO and GEO, reducing the risk of satellite collisions. Lastly, there's highly elliptical orbit (HEO). This orbit has varying heights, with low perigee 300-1,000 kilometers and high apogee above 35,786 kilometers. It's a highly elliptical orbit with the apogee point far from Earth. This allows satellites to spend more time at apogee, providing extensive coverage over one hemisphere. HEO is commonly used for Arctic communication, utilizing MOLNIA orbits to provide communication services in polar regions inaccessible to GEO satellites. It's also used for Earth observation, such as weather and high-altitude observation satellites. Well done, you haven't forgotten what I explained to you when you were young, Grandpa remarked. Alright, now Grandpa has finished resting and will continue his explanation. There are also some special orbits that you should know. First, there's the Sun synchronous orbit. This orbit allows satellites to cross the equator at the same local time every day. It's useful for weather observation and imaging satellites that require consistent timing. Then there's the polar orbit. These satellites pass over the north and south poles on each orbit, providing global coverage. It's ideal for weather observation and Earth surveying. Next, Grandpa will explain, or more accurately summarize, the reasons for choosing or not choosing specific orbits for satellites. Let's start with LEO. The launch costs for this orbit are lower, travel time is shorter, and it offers high-resolution image capabilities for observation. However, atmospheric drag causes orbit degradation and requires periodic adjustments. Next, for GEO, its advantage lies in its fixed coverage over one area, ideal for communication and weather observation. However, the launch costs are high, and periodic position adjustments are needed to counter drift. Moving on to MEO, this orbit strikes a balance between wide coverage and resolution, suitable for global navigation. Unfortunately, this orbit isn't fixed in one place, requiring satellite constellations for full coverage. Lastly, HEO. Its strength lies in long-term coverage over specific hemispheres, suitable for polar communication. However, its highly elliptical orbit requires adjustments to maintain stability. Are there any questions, my grandchildren? Grandpa smiled and continued to explain. Oh, that's the International Space Station (ISS) is a space station that serves as a microgravity research laboratory. The ISS is the result of international collaboration between NASA, United States, Roscosmos, Russia, JAXA, Japan, ESA, Europe, and CSA, Canada. It consists of several connected modules, including research modules, crew living quarters, and storage modules. There's Zarya Dawn, which was the first module launched, serving as the control and storage unit. Then there's Destiny, the U.S. laboratory providing research facilities. Kibo, the Japanese experiment module with open space facilities for space experiments. Columbus, the European laboratory module for scientific research. Solar panels are used to generate the electricity needed for ISS operations. The Canadarm2 robotic arm is used to assemble modules and capture cargo spacecraft. There are various main missions conducted by this spacecraft. First, scientific research, which includes experiments in biology, physics, astronomy, and materials science under microgravity conditions. Second, technology development, meaning testing technology that supports long-term space exploration. Third, international cooperation, to enhance international relations through scientific collaboration. And, Dad continued, there are many interesting manned and unmanned space missions. Let me tell you about some of them. For manned missions, I'll start with Vostok 1 in 1961, operated by the Soviet Union. This was the first manned space mission with cosmonaut Yuri Gagarin, who became the first human in space and orbited the Earth. The mission duration was 108 minutes. Then there's Apollo 11 in 1969 by NASA. This was the first manned moon landing mission. Astronauts Neil Armstrong and Buzz Aldrin walked on the lunar surface while Michael Collins remained in a command module. The mission duration was 8 days. Then Skylab from 1973 to 1974, also by NASA, was the United States' first space station, serving as a laboratory for scientific experiments in microgravity. Then there was Mir from 1986 to 2001, operated by the Soviet Union, Russia, the first modular space station, serving as the longest inhabited space habitat of its time and hosting various scientific experiments. Following that, there's the International Space Station (ISS) from 2000 until now, planned for retirement soon, operated by NASA, Roscosmos, ESA, JAXA, CSA. It is the largest space station ever built, serving as an international platform for scientific experiments, technology development, and international collaboration. And, continued Grandpa, cutting into Dad's explanation, there are also several notable unmanned missions. For example, Sputnik 1 in 1957, operated by the Soviet Union, was the first artificial satellite to orbit Earth, marking the beginning of the space exploration era. Its mission duration was 21 days transmitting signals. Then there's Luna 2 in 1959, also operated by the Soviet Union, the first spacecraft to reach the surface of the moon, confirming that the moon lacks a strong magnetic field. Following that, there's Mariner 2 in 1962, operated by NASA, the first spacecraft to successfully fly by Venus, gathering data on its atmosphere and temperature. The mission lasted for 4 months. Then there's Pioneer 10 from 1972 to 2003, operated by NASA, the first spacecraft to pass through the asteroid belt and fly by Jupiter, sending back images and data. Next, Voyager 1 from 1977 until now, also operated by NASA, the first spacecraft to reach interstellar space, capturing images of outer planets like Jupiter and Saturn, sending back the pale blue dot image of Earth. Galileo, from 1989 to 2003, operated by NASA, the first mission to orbit Jupiter, extensively studying its atmosphere, moons, and magnetosphere. Cassini-Huygens, operated from 1997 to 2017 by NASA ESA-AC, explored Saturn and its moons, with Huygens landing on Titan and sending back data on its atmosphere and surface. There's also New Horizons from 2006 until now, also operated by NASA, the first spacecraft to fly by Pluto, sending detailed images and data about Pluto and its moons, continuing to explore the Kuiper Belt. Lastly, the Mars Science Laboratory Curiosity from 2011 until now, also by NASA, a rover exploring the surface of Mars to search for signs of past life, studying the geology and climate of Mars. And finally, the Parker Solar Probe from 2018 until now, operated by NASA, the first spacecraft to explore the outer atmosphere of the sun corona, aiming to understand solar wind and solar activity. Well, perhaps that's all from Grandpa. How about it? Fascinating, isn't it, grandchildren, for today's discussion? Both grandchildren nodded. Very interesting, Grandpa, Dad. We've just started to understand so much about orbits, satellites, and spacecraft. We can't wait to learn more, Aster replied. Cosmo agreed. If that's the case, we'll work hard to learn even more. Have you finished reading the book Grandpa lent you? Grandpa asked. Yes, Grandpa, both grandchildren answered. We've been rereading it every day to understand it better. Good, very good. In that case, Grandpa will give you another book to read later. Well then, let's enjoy the night sky with many bright shining stars, said Grandpa. The family lay down together, gazing at the starry night sky. And that concludes today's episode of the Stellar Twin Voyagers. Fun, wasn't it? Would you like to hear more amazing stories from the adventures of our young shepherd who is writing their story amidst the millions of twinkling stars in the night sky? Therefore, stay with us on this program, and we will meet again in the next episode. In short, I'm Nova A239, delighted to share stories with you.